Hi, I'm Andrew, and this is my third lab report. So the main purpose of this lab is to utilize the Biot-Savart law and learn about the distance dependence of a small bar magnet's magnetic field. The main models and physical principles are the Biot-Savart law, which models the magnetic field based on moving point charges, and also the magnetic field of a dipole. We can model a bar magnet as a dipole, and thus they create a magnetic field. There are three different formulas for whether you're on axis, perpendicular axis, or off axis for calculating the magnetic field. And also there's a distance dependence formula which relates the distance from the magnetic field to the actual magnetic field, or distance away from the object to the magnetic field. And the preview of the results is the dipole moment is around 10.175, and I used the glow script to model the magnetic field around the bar magnet through different axes, and also found the magnetic field on the off axis as this. And then for observations, so first I measured on axis, which was on a east to west meter stick, and I would calculate the distance from the bar magnet at various magnetic fields. And same thing for off axis, so I would go I would just calculate off magnet distance or magnetic field, and based on the distance, and this is my observation numbers. And then also this is the a plot of the magnetic field versus the distance, or the logs of them. And the main assumptions are the bar magnet is a dipole and distance dependence of a magnetic field. So that means that as the further away you get from the bar magnet, the weaker the magnetic field gets. The system is the phone and magnetometer, and the surroundings is the bar magnet and earth. So the experiment, so I used the magnetometer app on my phone, slide the phone vertically and horizontally along the meter stick to determine where the magnetometer was, as shown in this one, in this image, where the crosses of tape intersect. That's where the magnetometer is. Then I would measure for on-axis and off-axis measurements for the magnetic field, of which I obtained the results in the previous slide. Specifically for off-axis, I used the same distance vertically and horizontally, and calculate that magnetic field there. So for the calculations, I used the distance dependence formula. I found that n is for this is going to be the slope of this log graph, and then I calculated for k, which is just some constants, and I set r to 1, and then I found that the dipole moment through this formula, through equating the magnetic field to the Biot-Savart law, I found it is 10.175. Then for the code, so as I showed earlier, this is the result of it. And for the code, I inputted my calculated mu, or my calculated dipole moment. I created the function for the calculating the dipole moment magnetic field, or dipole magnetic field. And then these are just me creating the arrows for the perpendicular and on-axis magnetic fields. And then, so the result from the experiment, this was my magnetic field, and then from the code, I guess they're a bit off, but there are a few sources of errors. For example, human error, so the magnetometer location, and then calculating the various other locations on a mirror stick. It was very crude measurements. And then additionally, other electronics nearby could have changed the magnetometer reading. Okay, for the discussion questions, what if I hadn't oriented my experiment to compensate for magnetic north and had instead laid out my mirror stick at some intermediate angle with respect to Earth's magnetic field? So the magnetic field from Earth would have altered the calculated magnetic field's x and y values, assuming the phone is still laying flat, and that would have altered all my other calculations. And then what if I were to stick two identical magnets together end to end and run the experiment again? How would my measurements differ? So I'd expect the magnetic field magnitude to probably double but then the direction would probably be the same. Thank you.